Sketch-based visual query interfaces provide freehand sketching as an efficient means for time series query formulation. However, existing manually constructed interfaces are rarely adopted in real-world scenarios as they do not facilitate bottom-up search. In this video, we demonstrate a novel data-driven sketch-based visual time series query interface construction system called Sensor. Given a time series dataset with class labels, Sensor automatically populates various panels of the interface from the dataset. The key feature of Sensor is the data-driven exposition of shapelets that are discriminative, have high coverage of the dataset, and within user-specified ease of visual interpretation to facilitate sketching. These shapelets act as representative objects to facilitate bottom-up search. The interface consists of 5 panels. Panel 1 enables a user to select a time series data source, specify input parameters for the data-driven construction, and load previously generated shapelets. Panel 2, referred to as Data Panel, shows the selected time series data. Panel 3 and 4 are Pattern Panel. They visualize small-size common shapelets that occur in most datasets and data-driven larger shapelets selected from the underlying dataset, respectively. Panel 5 is used for freehand and scale-less sketching of a query. A user may drag and drop shapelets to sketch a query in shapelet-at-a-time mode. We shall now demonstrate the features of Sensor using the real-world ECG200 dataset. Each series traces the electrical activity recorded during one heartbeat. We will see how Sensor creates the visual interface in a data-driven manner and facilitates visual query on the real-world dataset. After choosing the dataset, a user can set various parameters through the configuration panel in Panel 1 to automatically construct the VQI containing shapelets in Panel 3 and 4. Here we set the number of shapelets, K, to be 2. The shapelets in Panel 3 are common shapes like spike, sink, plateau, valley, rise and drop. Common shapes occur in most datasets and hence are provided as default for all. The shapelets in Panel 4 are canned shapelets generated from the current dataset. They are discriminative, have high coverage of the ECG200 dataset, and satisfy the user-specified thresholds for visually salient turns. We change the parameters based on a user's requirements and generate shapelets again, highlighting the data-driven nature of Sensor. Now we change the number of shapelets to be 24. Then there will be 24 shapelets generated as we set. Observe that the new shapelets in Panel 4 are obviously different from the previous ones. They have lesser visually salient turns based on the user specification. Later we shall further show the data-driven nature of Sensor by changing the dataset as well. Let us demonstrate now the construction of query. A user can sketch a query in different ways. First, one can directly select a shapelet as a query. This is typically the case for top-down search when a user has a pattern in her head to search. Fibrillatory waves are found of the surface 12-lead ECGs of patients in atrial fibrillation. They are oscillations in amplitude around the baseline and are dependent on the magnitude of the underlying voltage. Hence we select this shapelet as a query for fibrillatory waves. Observe that when we try to sketch the same shapelets on the query panel, it is hard to replicate it accurately by sketching due to biomechanical and cognitive constraints on humans. Hence, these canned shapelets has the potential to alleviate the challenge of sketching a shape. Second, a user may not have a pattern in her head. Hence, this demands support for bottom-up search. To this end, a user can browse the canned shapelets and use them as representative objects to trigger a search. She may simply drag and drop one or more shapelets of interest to the query panel and modify them in any way according to her needs. The query constructed in Panel 5 is similar to the ECG pattern of ventricular fibrillation, which is often a fatal arrhythmia. ECG findings in ventricular fibrillation are usually chaotic irregular deflections of varying amplitude. It is obviously more efficient browsing the canned shapelets than browsing the entire underlying time series data. The query in panel 5 can be modified through shrinking, stretching, or removing irrelevant parts. Alternatively, she can view a shapelet of interest in panel 4 and then replicate it or a portion of it by freehand scale-less sketching in panel 5. Lastly, a user can also select different time series datasets to appreciate the portable and data-driven nature of sensor. Shapelets in panel 4 can be different for different datasets. Here we select the dataset coffee, which is a dataset about food spectrographs of Robusta and Arabica coffee beans. The generated canned shapelets are different from those generated from the ECG 200 dataset. In summary, the data-driven construction of sensor empowers efficient top-down and bottom-up search and portability of the interface across different application domains and sources. We have come to the end of the video. Thank you very much for your attention.